Welcome to Maths at Derby again. I'm revising at the moment for my statistics exam, and I've got a question from last year which I thought was really interesting and quite relevant, and it's about whether you've been playing with unicorns or whether you've been in contact with people who've been playing with not very well unicorns. So it's about diseases, basically, and the diseases in this case have come from unicorns. I've shortened this question just to concentrate on the testing side of it. So it is a much longer question, but for the time we've got now, so the question is, MaD unicorn disease, MUD, is on the rise. Every 10th person in the world now carries the disease. The test for MUD is reasonably accurate, but not perfect. It detects the disease in every 10th non-carrier. So the question is there enough information to find the probability that the person has MUD given that the person tests positive, and then calculate the probability. So first we need to see what's going on, and my box here is represents all the people in the world, and the question says that does actually indicate that 10% of the population actually has the disease, so that's 0.1. So that means by definition, this bit over here, all the people that don't have the disease will be 1 minus 0.1. So everyone else, that's the rest of the 100%, is 90%. And the question is asking us, what is the probability that you have MaD given that you've tested positive? And it will depend on how accurate the test is. So first of all, I'm going to ask how sensitive the test is. So for all the people that have the disease, so that's, just think of probabilities really as percentages, so all the people that have disease, so I'm looking at that box there, and I want to know how sensitive the test is. So if I've got MaD, what is the chances that you will actually test positive? So this is a researcher's question. Really, there's a bunch of researchers who's brought a lot of people that they know they've got MaD, and then seen if they've tested positive or not. And if everyone tests positive, that's 100%. If not everyone tests positive, that will be slightly less than 1. Now that would, so if it was 1, it would be the whole box. If it was less than 1, so not everybody that's got MaD actually tests positive, so a few get missed, then that sensitivity would be represented by that box there. Now the issue is that there are some people that actually test positive that are in this box here that don't actually have the disease. So the chances of you having MaD are a percentage of those that test positive that do have the disease, and a percentage plus a percentage of the people that don't have the disease and also test positive. Now the question does actually, it doesn't give us this bit of information here, so we don't know that. But what we do know from the question, that 1 in 10th non-carrier, people who don't have it, are test positive as well. So I'm going to just put that in a line at the bottom here. So basically I need to know, in order to get the percentage for this question, I just need to know what this is, this top line is, as a percentage of this plus this. So that just goes then underneath. So I then look at all the people again that do have the disease, multiplied by the sensitivity of the test. So I'm just really repeating the top line again. I'm just basically, that bit at the top I'm putting down here as well, but I need to add to that all the other people in the world that test positive. So all the people that don't have the disease, so the probability of the people that don't have the disease, and then who test positive as well, but they, given that don't have, given that they don't have MaD. That makes sense. Okay. So all the information that we know from the question. So the question tells us it knows all the people in the world that do have the disease. So you know, taken taken from a sample. So all the people that do have the disease, and that's at the bottom as well, so 0.1. By definition, we know all the people in the world then that don't have the disease, so that is 0.9. The question does tell us all the false positives, which is 10% of those people there, so we need to put that in there, so there's 10% of false positives. But what we don't have is this bit of the question here. So assuming that the test is relatively good, you'd be expecting this to be closer to 1. Not all tests are 100% sensitive, so probably it's reasonable to say something a little bit less than that, so 0.8. Now if you punch all those numbers in, this is the Bayes formula, by the way, to calculate this. If you punch all of those numbers in, and I did calculate it, is 47.06%. Now, just because you test positive, it doesn't mean that you have the disease, because it doesn't matter how sensitive the test is. What matters is how many people in the world don't have the disease and are also testing positive. There's just a lot more. There's just a lot more of them. So hopefully that's helpful, topical and relevant, and I'm going to carry on revising for my statistics exam next month. So yeah, thanks for watching.